Hello, everyone. Welcome to the third developer community meeting. Today, we're going to be looking at computer vision featuring the cats and dog competition. This is a very old competition where the goal is to basically classify whether a picture is a cat or a dog. As always, here's some links to stay connected with the club. And I'm going to close this and go to the competition itself. 8 years ago, it's a pretty old one. And basically, you have a bunch of pictures of cats and dogs, and you have to label as a cat or a dog. So I'm gonna take a different approach this time around. I'm not gonna actually have the notebook on the Kaggle website. I'm gonna have it on this Google Colab. So let me actually share that link. In the chat. And I'll post it in the Discord as well later. If you open up the link, it'll be over here in this page. You can go to File, and you can save a copy in your drive and edit it from there and run it yourself. Right. So here in the main one, let's import our libraries. You can, if you go to Runtime, go to the Runtime tab and change runtime type. You can go to a hardware accelerator and put GPU so that your model trains faster. It's gonna train really slowly otherwise. Convolutional neural network models tend to be really expensive to train, and what that means is that it takes long to train them. So here, the data, because I'm not on Kaggle, I need to get it from a website, and that's what I'm doing here. And I'm saving it into the temp folder. And where you can find this, you can go to Files over here in your Google Colab, go up a folder, and go over here to temp, and you'll see your images here. So we'll have cat and dog images. So you can also think of this. Imagine if you were tasked with a classification problem that didn't have to do with cats and dogs, and you just have your images and, let's say, reptiles and amphibians, and you just have a bunch of pictures there. Let's pretend that's happening. We're gonna make, well, let's see how many pictures we have. We have 12,501 pictures of cats and dogs. So then I'm gonna make some new directories. This is the structure that I'm gonna use for our data generators. I'll explain why it needs the structure later. And here I just made a function to split the data from the pet images. Hold on, let me refresh it. Here's the cats and dogs directory where testing and training sets. I'm going to be splitting all our images of cats and dogs into a training set and a testing set. The testing is what we're going to use for validation. That's what this function is for. And we're going to do a split of 90% train and 10% test. So here I'm going to get the amount of pictures in each. For the training set, it's 11,250, and for the testing set, it's 12,250. And if you want to see some of the pictures, you can go over here using the map image imread from matplotlib, feed it in a path, and then show it with the plot im show. There's probably a better way of doing this, but copying the path and pasting it over here is the way I'm using.
What if we do an F string? Could that help?
Yeah. Yeah, you can do that. Like have like instead of the path here, you can put F path or file path, something like that,
Yeah.
and
then
have
we
that
can-
there, and then you can change.
Right.
But I'm not doing that.
Okay. All right.
But if you want, you can change it so you can see more pictures of cats and dogs. But I'm gonna just have this here. All right, some cats and dogs.
Mhm.
Now we're gonna make our model. The main layers in our model are gonna be convolutional neural network, or conv2D. It's gonna have a depth of 32, 3x3 convolutions, an activation of rectified linear units. And what that means is that it basically ensures that we don't get negative values. So it will be either 0 or positive. And we'll have an input shape of 150 by 150 by 3. 150 by 150 is the height and width of the picture. And the 3 signifies that it's RGB. So it's going to be colored pictures. If you had a gray or grayscale image, you would only have a 1 here. So what this convolutional layer is going to do is that it's going to find the features of the image. So let's say for a cat, probably going to see, okay, this cat has this type of nose and these type of eyes. That's what it's going to capture in these convolutional layers. And the max pooling is basically just going to zoom in on those features. So find a feature, zoom in, find a feature, zoom in, find a feature, zoom in, find a feature, zoom in. And now you're going to flatten out the results. So you can put it into a dense layer, and then the output, which is going to be 1 and a sigmoid. And what sigmoid ensures is that the output is either going to be 0 or 1. And to compile the model, we basically have binary cross entropy, that's for the 0 and 1. And as an optimizer, I have RMS prop where you can put something else if you want, like Atom. For metrics, I have accuracy, but there's also other metrics you can put here, like precision, recall, or sensitive. I don't remember the last one. I think it was F1 score. That's what. So let me run this code cell, and I'll have the model. And here is, you can do model.summary for a Keras model like this, and it'll print out a nice summary for you. Right. And here is where I'm using the generators. Right. So I'm gonna go through it real quick, then I'll explain what it does. So first, I'm getting the training there, which is this right here. The training, the source, the root of the training there with the cat and dog images. I'm gonna initialize my generator, and this rescale, I'm basically scaling down all the pixel values by 255. And 255 is the max value for each RGB picture. So let's say it had a picture has, or a pixel has an RGB value of 155, 25, and let's say 35. It's going to divide all of these by 255 because that's the max value, and it's going to scale it down. Why do you want to scale it down? So the numbers are closer together and you don't throw off your model. Remember that these models, they don't like variance in the values. They don't like big numbers with big standard deviations. So having the numbers be close together is really good.
So
Right.
just to make sure we're standardizing the data?
Yeah.
No, normalizing.
Yeah.
Okay, all right.
So, and then in the last one, the developer community meeting, we did this with a standard scaler, and we scaled things down like that. But in this one, we're doing it from this generator class.
Okay.
Right. Now we are going to actually use the generator here. We're gonna have the training dir, this training dir with the cat and dog images. The target size, this is gonna scale down all the pictures. So this was scaling the pixel values, and this is scaling down the actual picture down to 150 by 150 pixels. So anything bigger will be scaled down and anything smaller will be scaled up. Batch size is 20. And what they mean by batch size here is that the model is going to be optimized like every 20 pictures. And class mode binary. Binary means it's going to be either 0 or 1. So it's either going to be cats or dogs. And we do the same thing with the validation. So why am I even doing this? In the last developer community meeting, I just put everything in a pandas data frame and fed it into a model. So why are we using a generator this time around? And the answer is pretty simple. I don't want my RAM to explode. So what do I mean by that? In the previous developer community meeting, we didn't have as much data, and it was also in text form. And we could easily fit all of that in RAM. But for image data, just one of these pictures or a couple of these pictures could eat up all the memory space in my RAM. And if you have, let's say, 160 or even greater amounts of gigabytes of picture data, you can't fit that all into RAM. It'll make it explode. So what you do instead is that you feed it into your model batch by batch using a generator. So the generator is just gonna put in to your model, okay, this amount of pictures, this amount of pictures, this amount of pictures, and it's not gonna be all at once. And that's why we're using it. Make sure I run that. I'm not gonna train the model right now because this took like 45 minutes to actually finish. So I'm just gonna show the result. It has an accuracy of 96% on the training data, and on the testing data, it has an accuracy of 97%. It was actually better over here. And one way to not miss when you have a better model in another epoch that finished earlier is you can actually put a callback into your model that will actually stop the model or save the best version of the model. And here I'm just plotting out the training and validation accuracy over time and the training and validation loss. Actually pretty close together. It's such a big model, it's expected. And then after I finished that, looked over the plots, they're okay. I can save my model. And it's gonna have, I can't show it right now, but actually maybe I can. Here. I'm gonna save my model and I can download it and use it for my Streamlit app. Hold on, let me hide these controls. So here is the app in question. The first thing I do when I'm making these Streamlit apps to deploy them is I make this helper file where I get the current working directory. I load in my model using the load model function from TensorFlow. I have these static files here where I can get my model. This is a CatDoc model that I saved over here. I can load that in, and then I have this function called predict CatDoc, where I'm going to feed in image path. I'm going to load it, turn it into array, make sure the dimensions are right, and then I'm going to use my model to predict that image and return the prediction. And for the app itself, it's pretty simple with Streamlit. The way you actually write or have the HTML show up is using this st.write. If you import Streamlit as st.write, and this text right here, this is markdown. So what does this mean? This pound right here is h1, basically an h1 tag in HTML, which is like a header tag. And this will make this a header. And then this will be normal text. And then this is a horizontal rule. It's basically just a line or horizontal line that'll separate. So then we have the save upload file function. This is to save the file because these Streamlit apps are deployed on Docker. And if you don't know what Docker is, it's basically a virtualization software where you can have like an app running on a virtualized container. So I'm saving the uploaded file of a user uploads a file, and I'm saving that locally in the Docker image. I'll show you what that means later. And here, basically assigning the uploaded image from the front end to a variable. And I'm using, and after the user presses a button, I'm basically doing, going to display it, get a prediction on it. I'm using the local path of that Docker image where I've saved that file. I'm removing the picture after I'm finished with it, so it doesn't stay there forever. And then I'm showing the results. So let me show you what that looks like, hopefully. And it doesn't. It's still going. But one thing I can do here, I was really hoping that was working by now. This took forever to actually run. Yeah, it's still. All right, whatever. I'll show you guys using the local host way. Once you have Streamlit installed using pip, you can do Streamlit run and the name of your main file. And your main file is where you have all those Streamlit stuff. And for me, it's app.py. And it'll open it up on the local port. So this is what I'm talking about. This is the header file. The header tag with the text, normal text, the horizontal rule, the upload image stuff. You can browse your files, upload an image. Let me see if I have a cat image here. and you can press predict. It will display the image, and it won't show, at least on my computer locally, it won't show the model prediction. That's because I have TensorFlow GPU and it's screwing around. It's screwing around with the GPU, and I don't want that. But that's why I was really hoping this was working. But what should show up is after the prediction, an H2 tag would say, my model thinks your picture is a dog or a cat based on the prediction result. So if it's a 1, it's a dog. If it's a 0, it's a cat. All right. Any questions? It went really fast. I'm gonna open the floor to questions.
I mean, do you have to make the app of function by yourself, or is it created automatically when you export it?
What do you mean?
So like when you launch the HTML file for you to upload the image, that gets created like that. Yeah. Do you, is that created when you export it as an H5 file? Does that make sense?
Oh, you want me to actually deploy it in or share it with Streamlit? Right. Let me go over that. So what you need to do to deploy it with Streamlit, first, you make a GitHub repo, and you basically copy over all your code. And you need to make a requirements.txt, which is basically the libraries you're using.
Okay.
And the way to do that is you go over here to your command line. You go pip freeze, and then you can do requirements. This is greater than, it's redirecting to a file. Requirements, let me say txt, and you'll have your requirements. Right now, this is a lot. What I usually do is I get the main ones I'm using. So let's say I'm using TensorFlow. Basically just delete everything that I'm not using, because he'll probably install that stuff anyways. So I just use. Second turn. It's not as tedious as writing them down. That's for sure.
That's good.
All right, I think that's it. Yep. That's what I do.
Cool.
It worked for the last one. I don't know what's the problem this time around. I think it's just taking its time. Yeah. So, I mean, that's pretty much it. Oh shoot! So I needed to. Yo, sorry, Paulino. I didn't see you joining. Right. So let me explain this Docker image stuff. So it's basically an online, let's say, operating system. But it's miniaturized. And in this miniature operating system, you install all the stuff, the requirements.txt. Alejandro, this is like a Conda environment for you. in your case, you would install everything and you would have it all in your environment. And in this environment, you can run the app just like I did right here in my command line. It'll run it over here in this command line for a Docker image. And I'll have it, it should have it up, but it's not working right now. Well, it's taking sweet ass time, that's for sure. All right, any other questions then? Well, if you want to look into convolutional neural network models more, I definitely recommend looking over right here, this deepai.org definition. I'll have that in the Discord. And for those of you that joined just now, let me try to get the into the drive again. For attendance. You can take attendance here. And while they're taking attendance or putting in their attendance, any other questions?
I mean, it seems pretty straightforward, I'd like to think.
It is. TensorFlow really does make it easy.
Okay. Yeah, no, TensorFlow is awesome. On it, like the most difficult parts being, splitting it into the training test data, then training it, then fitting it, all of that stuff.
I mean, fitting it isn't really that bad, to be honest. It just takes time.
Helps. Yeah.
Pooling definitely does help.
Yeah. But
I mean, you can also, there's also different types of pooling. I did max pooling, but there's also average pooling. You could try that, see if that makes it better or worse.
Is pooling something that you use exclusively for images, or is it just like one of those things that's best used for images? Does that make sense?
I think it's best used for images.
Yeah.
You can use it for other multidimensional data, but I don't know what the effects would be. Yeah.
I'm guessing audio is like a whole different beast.
Yeah.
Yeah.
I've seen people use convolutional neural networks for audio, but I mean, I think some of them, I was doing research for, if you haven't taken attendance here, I was doing research for detecting deep fakes, and we were using convolutional neural networks with self-attention to classify whether an audio clip was a deep fake or not. So that's an application.
Wow.
All right. Any other questions on anything I went over? All right. If there are no other questions, I will end the meeting here.
Okay.